Hello, everyone. Good morning, good afternoon, good evening, wherever you're listening from. So today we're talking about we're going into talking in cybersecurity, like I said in our previous class. Um, Firstly, we have to know what's a network and what builds up a network. So a network is an interconnection of connection of systems, computers, so they can communicate and also share resources. Right? So, as a cybersecurity professional, what you need to understand is how these systems, how do they communicate? What allows them to communicate? What module, what protocol allows them to communicate and share resources? And how resources have been transferred from one system to another, right? So we have different types of network. We have the local area network, which is the LAN. We have a WAN, the wide area network. We have a MAN, a metropolitan area network, and also have a PAN, a personal area network. So moving on, we'll be breaking down these types of network and the modules and how this network functions. So we said networking for cybersecurity, a practical intro guide how network works and how to defend them. So cybersecurity is largely about understanding communication, who is communicating, with whom and how and why, and whether that communication should be trusted. So today we'll be talking about what we're going to learn today. We're going to learn how computers communicate on a network, how IP addressing and switching works, how common services like DNS and DHCP work, how firewalls and network defenses filter traffics, how attackers abuse network protocols, and how to analyze traffic and reason about an alert. So I've been introducing you guys to some tools. An example of those tools is Wireshark, for instance. It's used to analyze traffic, analyze packets on a network. So network fundamentals. So what's a network? Like I said, a computer network is a collection of connected devices that communicate and exchange information. So once these systems are connected, you're able to share resources, interact with each other using different protocols and different modules to communicate. All right, so it's our common devices here. We have our computers, our servers, phones, printers, routers and switches, firewalls, and cameras. Then why networks exist? First thing, they share resources, share information, access applications, and access the network. Then how does it come into, how cybersecurity comes into this? So that every device is a communication endpoint. Then it's also an attack surface. Then it's also a source of evidence when an attack has occurred. So how does this communication work? The first thing there is the basic path. It moves from a computer into a switch. From the switch, it goes to the router, and the router, it goes to the internet. From the internet, it moves into the web server. So firstly, a switch is used in connecting multiple devices. Right? This is how it works. So this is the basic part of the network. Your PC is here. It goes to your PC. It goes to a switch. And from the switch now, it goes to a router. a router, and from the router it goes to a web server. Right? This switch here is used to connect multiple devices. All these are devices. Let me name them D. So a switch is used to connect multiple devices. Why? A router is used to connecting multiple networks. Let me use this as a network. And for the network. Right? Then the next thing there says every message answers. Who is sending this message? Who is receiving it? And which application is used in sending this message? And how should it be delivered? So moving on, we're going to break this down. Then you say what traffic contains. The traffic contains the source, destination's address, the protocol, ports, application data. This is what an analyst examines. So at the end of the day, this traffic that moves from systems to devices are called traffics, right? So these traffics are what an analyst, security analyst, analyze to see if it's an abnormal behavior. Is it clear? Okay. So the job of those analysts now is to understand, okay, where is this information coming from? Doing an analysis on the source, and also doing an analysis on the destination is going to. Is it clear? And moving on, the LAN and the WAN, like I said, we have different types of networks, but I'll be talking about the main two types of network we have. We have the local area network, which is used in our offices, our homes, just a small network, right? In your office, use the local area network. In your house, local area network. And your small businesses, wide area network, which is the one now, covers a large geographical area like the internet, right? So it said the local area network is a small geographic area, which is your home, your office, a school, a data center. And the wide area network, it connects network across large areas, like your office to the internet and an office in office B, maybe a different branch entirely. Is that clear? So our next part, we're going into the network models. The network models are actually a model that allows this network to function, allows this communication between systems. Have you heard of the OSI model before? OSI model. Yes, the open system interconnection layer. And we also have the TCP and the IP model, right? Those models, they allow network to function. Those allows this communication between systems, right? So we're talking about the two models. The first one is the OSI model. The OSI stands for Open System Interconnection, that has 7 layers. OSI, Open System Interconnection. So the OSI model has 7 layers. The first layer there is the physical layer. The second layer is data link. The third layer is the network layer. The fourth layer is transport. The fifth is the session. The sixth is the presentation. And seventh is the application layer. All right. Okay. All right. So the material here is not two models. Yeah, we're just not gone too far. All right. So here the networking is divided into layers, each performing one specific job. This makes troubleshooting easier and lets different technologies work. So we have two important models: the OSI model, which I just broke it down the layers. That's 7 layers. The TCP and the I model, which is the model the real internet runs on, right? On the internet, it uses the TCP and the IP model. On the local area network, we use the OSI model. Okay. So instead of remember these layers, there's an easy way you can remember this layer: the physical data link, network transport, section, presentation, and application layer. It's either you take it from 7 to 1 or 1 to 7. It goes both ways. So to make it easier for you, you can just say all people seem to need data processing. An easy form to or easy way to understand these layers, to know these layers. APSTNDP, which is application, presentation, session, transport, network, data, and display layer. So an easy way to understand this, you just say all people seem to need data protection. It's quite easy, right? Instead, layers from 7 down to 1. So it goes from here, 7 to 1. TCP/IP, right? So you know the network. I think I explained the network the last class, right? So we went deeper into it. So this model, what allows this network to function, right? What allows this communication between system, setup, and all that, right? It has two different models. The OSI model works on the local area network. TCP and IP model runs over the internet. It's clear. All right. Then the OSI model from 1 to 4, the first layer is physical layer. So it transmits raw bits, which is the first layer there. An example of tools of that physical layer, we have the cable and radio fiber. Here, physical layer, like I'm saying, cables. So these transmit raw data. Right, this cable, and we have radio, then we have the fiber. Then two, we have the data link. It said data link is local delivery MAC address, which is the frame. So the data link it uses the MAC address table. I will explain the MAC address for you guys. Then it consists of the internet, switches, and ARP. Then the third layer, which is the network layer, right? It's also called the routing layer, right? Traffic. No? The routes between networks by IP. So on the network layer, that's where the IP comes in, routing of information from one device to another device within the network. Is it clear? All right. Then it says IP addressing and routers. So 3 router. Then 4 is the transport layer. This is the transmission of data, delivery of data from one application to another, from one system to another. Is it clear? So these two protocols, the TCP and BDP protocol. The TCP stands for Transmission Control Protocol. TCP transmission control protocol, and the UDP is user data protocol. Right? So these two protocols is what allows delivery of traffic between systems on the network. The TCP there is connection rated, right? I communicate. So we have the well-known ports. Okay, what's in this? Ports. The total number is 65,535. Well-known ports. The well-known port now ranges from 0 to 1023. Then we have the registered ports.
Sorry, it was
65,535. Yes. 535. 65,535. All right. Then we have registered ports ranging from 1024 to 49,151. Then we have dynamic or private ports. Ranging from 49152 to 65535. So these well-known ports now, they run on global network services, just like the HTTP, HTTPS, DNS, yes, Telnet, SMTP, POP3, and all that. They all fall under this range. They have global services, while the registered ports are used by specific applications, like my SQL database, for instance, right? They use this port 3000. It's an application using the database, managing the database. It uses a particular port which falls under the registered ports altogether. While the dynamic and private ports, they are used by operating systems, but it's not commonly used. Question? Right. So that's that for port. So moving on, we'll still come back to this. Then the layer 6 is the presentation layer. I also call it the format layer. Layer 6 is format layer or presentation layer. It said the format, encode, and encrypt data. That presentation layer is the format at which you see those data, or the format at which you get those data. It could be an encrypted data. It could be a JPEG, a picture. It could be a PDF. Is it clear? All right. It said encryption or encoding. Then the layer 7, which is the application layer, said the service the user interacts, which means the application you interact with. Is it a browser, a software, whatever means you are interacting with that service. It uses HTTP, DNS, SMTP, and SSH protocol. Any question? All right. So the next part that we're talking about is network encapsulation. So network encapsulation here, right, is a process of wrapping data or any extra information as it moves between layers on the network. Like for instance, now I'm sending traffic on the network from the layer 1 that has the raw data. What it does now, it can encapsulate it with the source, the IP, and destination down to data link. It has other information, send it down to the network, wrap the information and data it wants, send it to the transport, down till it gets to the application layer. Is it clear? Right? So, Z encapsulation, each layer wraps the data with information the next layer needs. This wrapping is called encapsulation. The flow, how it flows from application, data, transport, TCP UDP header, which transmit data between systems. The network uses the IP header, and data link use the internet header. All right, then he said, what? Yes, the flow is backwards. Is it clear? It goes down and goes up back. But why is doing this now? It wraps every data, every information. It takes it to the next layer wraps the information, takes it to the next layer till it gets to its destination. Okay. Then he said, name each layer. He said application is data, transport is segment, network is packet, the data link, which is layer 2, is the frame, the physical is the bit. Then switching and MAC addressing. Like before I move on, what is a MAC address? Right? Want to answer? Any person. Where heard of a MAC address before? Right? So a MAC address is a unique identifier that comes with every device, right? Your media access control, yes. It comes with every device, unique identifier. That, okay, for instance, let me say my name is John. Everybody knows me as John. That's my unique identifier. Then there's a place I will go to. Then some people call me Johnny. I go to another place, they call me Jay.